Hi guys, sorry I couldn't be there today in class, but we still have to drive forward here. We do not get to take a day off just because I'm not there. Okay, so we are going to walk through the lecture just like we would in class, but I'm going to do it in an abbreviated form through this video. Okay, so what I'm going to ask is that you have your workbooks, your math workbooks, open with you while you're watching this on your iPad. Okay, you are welcome to pause this video as many times as you need or as long as you need so that you can fill this out and work along with me here. Okay, I will be taking this for a grade, all right, and I will be checking your workbook, so please make sure that you are following along with me here. All right, so moving on here, lesson 5.2, we are going into this thing called domain and range, okay? And we're now talking about that with our functions, right? And we talked about that with a function, we have to have one output for every input, okay? So again, moving forward, the set of all inputs for a function is known as the domain, okay? And the set of all outputs is called the range, okay? So before we even jump forward here, okay, we talked about our x being our input, right? And that goes to our y, which is our output, okay? So if we had a function, right, 2, 3, and 4, okay, 2 goes to, 1, 3 goes to 0, 4 goes to -1, okay? That is a function because every input has exactly one output, all right? And let me start to color code here, okay? The domain is the set of all the inputs, okay? So our domain here would be this. It would be 2, 3, and 4. Versus our range of the function, which is the set of all the outputs. So 1, 0, and -1. Okay? So if we consider a vending machine where we insert 25 cents for 1 pencil, okay? Inserting 50 cents gets 2 pencils and so on and so forth up to 10 pencils. Identify the domain in this situation. So that means what are all the inputs that we could have into this vending machine, right? So start off here, I could obviously input nothing, so that would be a 0. I could input 25 cents, I could input 50, 75, $1, 125, 150, 175, $2, 225, all the way up to 250, okay? Because it said here I can get up to 10 pencils, okay? So I can get up to 10 pencils, all right? Now, the range for this situation here would be how many pencils I can get. I can get up to 10 pencils, right? So if I put in $0 or 0 quarters, I'm going to get out 0 pencils, okay? 25 cents would give me 1 pencil. 50 cents gives me 2. 75 gives me 3. $1, it gives me 4. 125 gives me 5. 150 gives me 6, 7, 8, right? All the way up to, that's how we got to the 250, right? If I put in $2.50, I'm going to get out 10 pencils. All right, so then moving on to number 2, for each function, identify the domain and the range. Well, right, domain just means input and range means output. Okay, so our ranges are our outputs. And again, the domains are the inputs. Okay, so over here, I have an input of 7, 3, and 5. So that is my set, right? These squiggly brackets just mean set. Okay, so my set is 7, 3, and 5. Okay, my output or my range is 6, -2, and +1. Over here, right, my domain is my input. I got that label. My input, 2, 6, and 8. My output is 4 and -3. Okay. Moving forward to C and D. Again, we're looking for our domain and our range. Well, domain is our X value and range is our Y value. So in our xy coordinates, all of these first x values are going to be your domain. And all of these second values are your y's. That's going to be your range. Okay. For C here, right, it's the exact same thing. This is our x, which is our input or our domains. This is our y, which is our outputs, which is the range. So over here, I have an input of 2, an input of 3, and an input of 5. So my domain is the set of 2, 3, and 5. Then my range, right? I've got a y value at 4, at 1, and at 3. So my set is 4, 1, 3. Okay. Moving on down here, consider the machine that exchanges quarters for dollar bills. Oh, let me zoom back up, sorry. Exchanges quarters for dollar bills. Okay. Obviously, if we put in $1 bill, we're going to get out 4 quarters. Okay. So we can do that up to $5 bills at a time. So looking at these questions here, is 7 a possible input? Okay. Can we input $7? Right? That's what it's saying here. And no. Okay. So again, I'm going to make sure we're all on the same page. Input is our dollars. How many dollars are we inputting? Okay. And that's going to go towards our output. And our output here is quarters. So again, can I have an input or can I put in $7? The answer is no, because right here it says up to 5 $1 bills at a time. Letter B, could 3.5 be included in the domain? Okay, well, the domain is our inputs. So can we input $3.50? Well, no, that's silly, right? We have to input a whole number of dollar bills. Okay. Letter C, what values are not included in our domain, right? In our inputs. Okay, so that would be any value other than our whole numbers, right? We have to put in a whole number. Right? That's the trick here. For the dollar bills, we can put in $0, right? We'll get nothing out, obviously. We can put in $1. We can put in 2, 3, 4, and 5, but we can't go more than 5. Why? Because that's what was given to us in these conditions. Okay. Letter D is, and let me grab this guy here and bring it down with us so we don't forget. Okay. So, letter D, is 8 a possible output for this machine? Can we have something that gives us 8 quarters? The answer is yeah, absolutely. Right? If we put in $2, we are going to get out 8 quarters. Okay? So yeah, we can get out 8 quarters for $2 bills. Letter E here. Could 3 be included in the range of this relation? So again, talking about range, that's talking about our outputs. The answer is no, because 3 quarters would only be 75 cents. And we have to input a whole dollar, so it wouldn't even make sense. Okay. And the last one here, what values are not in the range? Okay, so range is talking about Y values. Okay, what are our outputs? Well, that would be anything other than quantities of 4. Because again, 4 quarters make $1, and we have to input a whole dollar. So here, I input $0, I get out 0 quarters. I input $1, I get out 4 quarters. I input 2, I get 8. $3 gives me 12. $4 gives me 14. And if I put in the max of $5, I'm going to get out 20 quarters. Okay. Then the next one here, number 4, make sense of this problem. Each of the functions that you've seen has what's called a finite number of ordered pairs versus infinite or infinite. Okay, so we're going to go over here. A finite set has a fixed countable number of elements. Okay, so finite is fixed. Okay. Infinite has an unlimited number. Okay, so if something is considered finite, that means it has a fixed number, a set number. Other things are infinite. Okay, infinite means it has an unlimited number. Okay, so for example here, it says describe any difficulties that may exist trying to represent a function with an infinite number of ordered pairs using the four representations of our functions that have been described so far, right? So our table, our mapping, our graph, and our ordered pairs. And what would happen here is it'd be impossible, right? Infinite means unlimited. So how I'd have to make a table or a graph or a mapping that just keeps going on and on and on forever, right? That would just never stop. So that would require unlimited numbers, okay? Now, moving on to number 5 here. Sometimes machine diagrams are used to represent functions, okay? In the function machine below, the inputs are labeled as X and the outputs are labeled as Y. So again, these are our outputs, and we learned a new word today, also called range. So these are our inputs, also known as our domain. Okay, so for example here, this is our function 2x plus 5. So we can input a value for x, and we will get an output of y. Okay, so for example, what is the output if the input is x of 7, negative 2, and 1/2, okay? And what you're going to notice here is you do the exact same math that we talked about earlier, right? You replace, right, using parentheses. Then we follow our order of operations. We have to do our multiplication of that parentheses first. Then we add, and you should end up with 19, 1, and 6. Okay, 19, 1, and 6. All right. Now, the next question says, is there any limit to the number of input values? So is there a limit to the number of x values that can be used with this expression? Is there any x value we can't put in? And the answer is no, right? You could make any number of x or pick any number of x, right? All the way from positive to infinity and negative infinity. Okay, there's no limit to what we pick for x here. Okay. If we look at this next one here, consider the function machine below. Oops, so let me grab these again. Okay. Talking about inputs and outputs, our x's and y's. Use the diagram to find the input-output ordered pair for the following values. So, again, that's telling us we need to make this as a set of ordered pairs. Input first, output. Okay, so if I input a negative 5, what is my output? If I input a 3/5, what is my output? I input a negative 10, what is my output? Okay, so you're welcome to pause if you'd like and try these on your own. Okay, but at the end of the day here, you're going to get your values. Okay, and I want to note something here. It is not just enough to solve for the answer. Okay, you were asked to create the ordered pairs. So yes, you solved for your output values, right? Or should have solved for your output values by replacing, right? Taking care of your exponents first and your multiplications, right? Should have gotten these answers, but those are just your outputs. You also have to include your input values. Okay? So your final answer here would be these ordered pairs, negative 5, 18. When I plug in a negative 5, I got out a 18. When I plugged in a 3/5, I got out a 114 over 25. When I plugged in a negative 10, I got out a positive 83. Okay. Now, before I get a bunch of questions here, yes, you can write it as fractions, you can write it as decimals, whatever makes you most comfortable. You can use mixed numbers if you'd like, right? Any of the following. As long as they are all the same, that's what matters. Okay? So, Moving on down. Number 7 says make a function machine for the following expression and use it to find the ordered pairs for x is equal to 3, negative 6, 0.25, and 3/4. Okay, so that's what my function machine looks like. I'm not an artist, so don't judge me here, okay? But then I have to make my ordered pairs. So again, we have to put input first, which is your x values. We have to solve to get our output values. All right, and that's what we solved for. And we write our final ordered pairs as x and y combinations. Forgot a parentheses there. Okay, so there you go, right? You're just going to solve. You'll replace, do your multiplication, and then do either your addition or subtraction to get your final output value for those 4 x values. Again, take some time if you need to. Solve them, check them, write them down. Okay. The next part says, by creating a function machine, okay, it can be time-consuming and awkward. Obviously, we don't want to draw this little thing out all the time. Okay, so the function represented by the diagram in item 5 can also be written algebraically. Okay, so rather than drawing this guy out or drawing, this guy or this one, this is the one we're talking about, rather than drawing this guy out here, we can just write it as oops, I went too far. Sorry. We can write it as an equation, right? So our output is equal to our function, right? Our output is equal to our function, okay? So for each function, then we are asked to find the ordered pairs. So this, again, is still your input. I am inputting these into my function. And what I'm solving for is my output of y. Okay? All right. And we would do that for there. We could also do that for here, for these new ones. Okay? I'm inputting my x values and I'm getting out my y values. Okay, and now you were asked to create a table. Okay, so when x is equal to negative 2, y is equal to something. Okay, when x is equal to 5, what's your y equal? What's your output? Again, 2/3, 0.75, right? You should get out these values. Again, I suggest that you should definitely be trying these. At least see if they make sense to you. Okay. So then, moving on to our last thing here. Okay, here's the check your understanding. It says this set of values represents a function. And again, why do we know this? Well, because every input, 3, negative 1, 2, and 0, only have one output. It is okay that negative 1 is output is 2 and so is positive 2. Right? It's just the fact that whenever I input a 2, I always get out a 2. Or I input a negative 1, I always get out a 2. Okay? So identify the domain and the range. Okay? So we would write that like this. Okay? Your domain is your x values or your set of your x values, and your range are your y values. So I have 3, negative 1, 2, and 0 as my domain, and my range is the set of 5, 2, and negative 1. Okay. Next one, find the domain and range of each function. So again, you're asked to find your input, right, or your x values. So x values, right, your domain, your input values, and you're asked to find the range, which is your y values. Your y values. Okay. So the domain here are all the x values. So negative 1, 0, 1, 2. Our range is 1, 0, negative 1, negative 2. Our domain over here is 12, 17, and negative 4. Our range is negative 8, 3, and 9. Okay. So there's your full answers in case I went too fast for you. Okay? So again, domain is your input or your X values, and your range is your output or your Y values. Okay? So now you have the entire rest of class to finish your lesson 5.2 practice on next page. Okay? So you are asked, or I am asking you to complete this for homework. Okay, so depending on how fast you went through this, you might have time in class right now. Okay, I am checking this on Monday in class. So this is going to be due Monday. All right, if you have it done, you'll get full points. If you have it not done, you'll get 0 points. Okay, very simple. You're not turning it in anywhere. You're just going to complete it in your workbook. Okay. All right, that's all I have for you. So if you have any questions, please feel free to reach out. Otherwise, make sure that you have those notes copied down in your notebook and you're giving these lessons 5 to practice problems a try. All right, thanks guys. Bye.